Hi everyone, welcome to our mathematics session. Today we will be focusing on how to calculate the volume of solids, right pyramid, cone, and sphere. Let us take a look at some key terms that we will be using in our session for today. The volume of a solid is the amount of space occupied by the solid. The greater the volume of a solid, the more space it takes up. And the volume of a solid is the number of unit cubes that the solid can be divided into. A solid is a three-dimensional object. It is not flat and it has three measurements: length, width, and height. A pyramid is a three-dimensional figure whose base is a polygon and all of the other faces are triangles. Here are examples of pyramids. Right pyramid. A pyramid is a right pyramid if the line between the apex and the center of the base is perpendicular to the base. Let's now take a look at volume of pyramids. Here to our left, the image is representing a pyramid and a prism. What do you notice about the volume of a pyramid and that of a prism? Any guesses? How much less? If you said 2/3 less, you win! Kudos! Do you know how to find the volume of a pyramid? Here we have a pyramid. The volume of a pyramid is found by multiplying 1/3 by the area of its base A by its perpendicular height h. Therefore, the volume of a pyramid equals 1/3 multiplied by the area of the base multiplied by height, which is our perpendicular height. Find the volume of the square pyramid with base edge length 9 centimeters and height 12 centimeters. What do you notice about the base of this pyramid? Yes, it is a square. And what do we know about the properties of a square in relation to the lengths of the sides? Yes, that's right. The lengths of the side of a square are all equal. So go ahead and try to find the volume of this square pyramid. Remember, we said that the base is a square and it has a side length of 9 centimeters and the perpendicular height is 12 centimeters. Let us check to see if you are correct. We know that to calculate the volume of a pyramid, we use 1/3 multiplied by the area of the base multiplied by the perpendicular height, which when we substitute our values, we have 1/3 multiplied by 9 multiplied by 9 multiplied by 12, which when simplifies gives us 1/3 multiplied by 81 multiplied by 12. And when we simplify this a little bit further, we have 1/3 multiplied by 972. Now get your calculators out if you were not using them before. Plug these values in your calculator and tell me what you get. That's right, 324 cubic centimeters. Therefore, the volume of our square pyramid is 324 cubic centimeters. Find the volume of this pyramid. What do you notice about the base of this pyramid? Yes, it is a triangle. But what type of triangle is this? That's right, it is a right angle triangle. How do we find the area of a right angle triangle? That's right, half multiplied by the base multiplied by the perpendicular height. So go ahead and find the volume of this pyramid. Let's see if you are correct. We know that to find the volume of a pyramid, we use 1/3 multiplied by the area of the base multiplied by the perpendicular height. And when we calculated our base, which is the base of our pyramid, we have half multiplied by 4 multiplied by 7, which when simplified gives us 14 squared centimeters. So now that we have the area of the base of our pyramid, we can go ahead and find the volume. So the volume of our pyramid equals 1/3 multiplied by 14 multiplied by 6, which gives us 28 cubic centimeters. Find the volume of this pyramid. What do we notice about the base of this pyramid? That's right. It is rectangular in shape. How do we find the area of a rectangle? That's also correct. We multiply the length by the length. So go ahead and find the volume of this pyramid. All right, let's see if you were correct. So we do know that to find the volume of a pyramid, we use 1/3 multiplied by the area of our base multiplied by the perpendicular height, which when we substitute our values, we have 1/3 multiplied by 10 multiplied by 12 multiplied by 8. When we simplify this, we have the volume of this pyramid is 320 cubic meters. What does this image represent to you? An ice cream cone? You're on the right track. A cone is a special type of pyramid with a circular base and a curved surface that gradually narrows to a vertex. Now we will be looking at the volume of a cone. Take a look at the cylinder and the cone as shown below. What do you notice about the diameter of both the cylinder and the cone? That's right, the diameters are the same. Therefore, the diameter of the top of the cone and the cylinder are equal. What do you notice about the heights of the cylinder and of the cone? You're also correct. The height of the cone and the cylinder are equal. Now, if you were to fill the cone with water and emptied it into the cylinder, how many times would you have to fill the cone to completely fill the cylinder to the top? Let's try and see if we can fill the cylinder. So that's one time, right? Good. Let's go again. That's two times. Let's try again. And that's three times. Therefore, we know that the cylinder has three times the volume of a cone with the same height and diameter. If our diameters are the same, we know that our radius will also be the same. The experiment on the previous slide allows us to work out the formula for the volume of a cone. The formula for the volume of a cylinder is pi r squared h. We have seen that the volume of a cylinder is three times more than that of a cone with the same diameter and height. We also know that since the diameter is the same, the radius will also be the same. So therefore, the formula for the volume of a cone gives us 1/3 multiplied by pi multiplied by r squared multiplied by h. And here we have 1/3 pi r squared h, where r is our radius and h is our perpendicular height. Let us now try and calculate the volume of the cones below using pi as an approximate value of 3.14. Let's go try this one on your own first, and then we will work it together. All right, let's work it together. As was said earlier, the volume of a cone equals 1/3 pi r squared h. We know that pi, the approximate value we're using, is 3.14. As we can see from our cone, our radius is 6 meters and our perpendicular height is 9 meters. Therefore, when we substitute these values in our equation, we have 1/3 multiplied by 3.14 multiplied by 6 multiplied by 6 multiplied by 9, which gives us 339.12 cubic meters. Good job. Try this second one now. Your time is now up. Let's work this out together. Again, we know that the volume of a cone equals 1/3 pi r squared h. In substituting our values for pi, r, and h, we have 1/3 multiplied by 3.14 multiplied by 9 multiplied by 9 multiplied by 13. I know some of you would have mistakenly written 18 instead of 9, but take a look and see if you can tell me what 18 meters represent. Yes, it represents the diameter. And what do we know about the diameter in relations to the radius? That is indeed correct. The diameter is twice the size of the radius. Therefore, our radius for this cone is 9 meters. Now, going back to our calculations, when we simplify this using our calculator, so plug your values in your calculator now, we should have 1102.14 cubic meters. Good job, guys. And because you have done so well on these two, I'm going to allow you to try a third one on your own. Find the volume of the cone with a diameter of 8 meters. Now, before you attempt, what can you say about the diameter? Yes, it is twice the size of the radius, which means if our diameter is 8 meters, our radius will be 4 meters. So go ahead and find the volume of this cone. All right, let's work it out together now. The volume of our cone is equal to 1/3 pi r squared h. And when we substitute our values, we have 1/3 multiplied by 3.14 multiplied by 4 multiplied by 4 multiplied by 10, which gives us 1/3 multiplied by 3.14 multiplied by 160. When we simplify this, we have 167.47 cubic meters. Good job. Take a look at this image and tell me what you think it is. The earth. All right. Anything else? A football. Yes. Anything else? A sphere. Yes, you're all correct. So now we're going to be taking a look at how to find the volume of a sphere. The volume of a sphere is the number of unit cubes or cubic units needed to fill the sphere. You can find the formula for the volume of a sphere by comparing it with the volume of a cylinder with a height and diameter equal to the diameter of the sphere. What do you notice about the diameter of the cylinder and the diameter of the sphere? That's correct. The diameter of a cylinder and a sphere are the same. What do you notice about the perpendicular height of the cylinder and the diameter of the sphere? That's right. The height of the cylinder equals the diameter of the sphere. What can we conclude when we place the sphere inside the cylinder in terms of its height and diameter? That's right. The cylinder has a height and diameter equal to the diameter of the sphere. Let us try an experiment with our cylinder and our sphere. Suppose we marked off the cylinder in thirds. And what happens when we fill the cylinder with water up to the 1/3 mark? But let's take it a little bit step further. If we place the sphere inside the cylinder, what do you think will happen? That's right, the water inside the cylinder rises. When the sphere is completely submerged in the cylinder, the water level reaches the top of the cylinder. To find the volume of a cylinder, we use pi r squared h. In this cylinder, we said the height is equal to 2r. So, V, our volume, equals pi r squared h, and in substituting 2r for h, we have pi r squared 2r, and when we simplify this a little bit further, we have the volume of this cylinder to be 2 pi r cubed. Since the sphere filled up 2/3 of the space in the cylinder, the volume of the sphere must equal 2/3 the volume of the cylinder. Thus, the formula for the volume of this particular sphere is volume equals 2/3 bracket 2 pi r cubed bracket, which is 4/3 pi r cubed. Determine the volume of the sphere. Use pi as 3.14. Okay, let's try this one together now. The volume of our sphere equals 4/3 pi r cubed. In substituting our values for pi and r, we have 4/3 multiplied by 3.14 multiplied by 9 multiplied by 9 multiplied by 9, which gives us 3053.63 cubic centimeters. Let us take a recap of what we did in class today. We looked at the volume of a pyramid, which is 1/3 multiplied by the area of the base multiplied by the perpendicular height. We also looked at the volume of a cone, which is 1/3 pi r squared h. And thirdly, we looked at the volume of a sphere, which is 4/3 pi r cubed. I am so proud of you all. You did well, and you can now calculate the volume of a pyramid, cone, and sphere. Keep practicing until I see you next time.